So, welcome back student to this mathematical methods 1 course where we are dealing with linear vector space. So, in last class if you remember we stopped one place. In the last class we studied about the basis transformation. And we show that a basis E I can write in terms of another basis E prime with a matrix T. This is a transformation matrix through which I can transform any one of the bases from one to another. If I do so, then I can also find in prime basis some vector component. This prime is a vector in prime basis, some vector component, and it will be something like this. So, the rule is if I know the T matrix which is transforming the basis, then I can also figure out what is the transformation of a given vector. This is in non-prime frame. I want to find out the vector component in prime frame. So, this is the corresponding transformation matrix. I need to transform that, and this T is related to the transpose of that we also show in the last class. And also we stopped one place by putting one problem, and the problem was my E is given as E1 is given as 1 0, my E2 was given as 0 1, my E1 prime was given as this, and my E2 prime was given as this. So, now the question was, if a vector, that time I wrote x. So, let me write it, say 2 5, this component 2 and 5 is in non prime basis or natural basis. So, I can write it as 2 1 0 plus 5 0 1 like this. In terms of E1 and E2, it can be represented like this. The question was, if I want to represent the same vector in prime basis, then what should be the value. So, this is box which I need to figure out, and it is E1 prime plus the box, this is E2 prime. That was the problem. So, let us do the problem right now. So, first we need to find out. So, rule, I need to write the rule somewhere here so that you can remember on the right hand side of the board. Say if E is related to E prime like this, V prime is related to like this. So, I need to find out the T matrix first. So, let me write E matrix in terms of, the first I need to write E matrix in terms of prime. So, if I do, then my E matrix E1 which is 1 0, I can write it as T 1 1 1 by root over of 1 1 plus T 1 2 1 by root over minus 1 1. T 1 1, T 1 2 I do not know right now, I need to find out because this equation is there. So, I can figure it out what is the value. So, if I write the equation from here I can have two equation, 1 by root over, if I take common, then T11 minus T12 is equal to 1, that is my equation 1. My equation 2 will be something like 1 by root over of 2, again I can take it common, T11 plus T12 is equal to 0. From this T equation I can solve easily and I can figure out what is my T1 and T22. From this equation I can readily have the information that T11 is equal to minus of T12. If I put it here, then my T11, I put this information here, so minus T2 will be replaced by T11 plus T11 will be root over of 2, and this gives me T11 is equal to 1 by root over of 2. So, T11 is 1 by root over 2, T11 is minus T. So, T12 is minus 1 by root over of 2. So, I can figure out two component T11 and T22. So, I should write somewhere here because I need to use that. So, let me write it here. Let me erase this. T11 I find as 1 by root over of 2 and T12 I find minus of 1 by root over of 2. Similarly, I will do the other equation, for other vector I can do the similar thing. So, I can write E2 which is 0 1. Now, this coefficient will going to change, I should write it at T211 21 and it is T22. I need to find out this also to complete the matrix. It will be a 2 by 2 matrix, T will be, so 2 component I figure out, another 2 component T21 and T22 I need to find. So, now with this equation also I can write one the similar kind of equation that we will find here, T21 minus T22 is 0, first equation. So, when the first equation is here, I can readily write from this equation that T21 should be equal to T22. Second equation I can write 1 root over of 2 T21 plus T22, this is equal to 1. T21 1 by root over 2 I take common, T21 plus T22, that is equal to 1. T22 and T11 are same, so I can write T21 plus T21 is equal to root over of 2, or sorry, it will be T21. So, T21 is 1 by root over of 2. If my T21 is 1 by root over of 2, this 22 is also 1 by root over of 2. So, another 2 value I will get, which is 1 by root 2 and 1 by root 2. So, all the 4 components of T I figure out. Okay, so my T matrix, how the T matrix will look like? 1 by root 2, I can take 1 by root 2 common, then it will be just 1 minus 1 1 1 like this. This will be my T matrix. Now according to the rule, if I want to find out what is the vector component in prime frame, I need to multiply T transfer T and this I need to make a transpose. So let me transpose that. So T transpose will be 1 minus 1 1 1. This is my T transpose. So I can just need to transpose that, and then I need to multiply with my original vector that is given in. So original vector according to the problem it was 2 5. So I should write here x1 x2 at prime frame, this component I want to know is equal to this matrix multiplied by the original matrix that is given. Fine. So I almost done the part. So I just need to figure out what is x1 and what is x2 by solving this. So let us solve and try to find out what I am getting is the correct thing or not. So x1 prime is simply 1 by root over of 2 into 1 and 5 into 1, so 7. It is coming like this, and x2 prime is coming as 1 by root 2 minus 2 plus 5, so 3. So two components are having like this and this by this treatment. So now how these things it look like? So let me write T matrix here somewhere, because I may be required to use that later. So my T matrix was 1 by root 2 1 minus 1 1 1. This is the transpose of that matrix, so that is why the minus sign is coming here anyway. So I got the component. So that means in non-prime frame, if I write x, this will be the first component 1 by root over of 2 multiplied by 7 into the basis, which is this, plus next component which is this into the basis. Now if I calculate that, then I will return back my old matrix 2 5 if it is correct, if these things are correct. So let us check also whether this is correct or not. So what will be this matrix? 1 by root over of 2, 1 by root over of 2, it will be multiplied and it will give half, here also half. So 7 and minus 3. So first component will be 7 minus 3 divided by 2, and the second component will be 7 plus 3 divided by 2. These are the two components in this form, and this is essentially my old matrix 2 and 5. So that means the vector always can be represented in form of his natural basis, which is 2 5. When I write any vector in this form, that essentially means that I am writing this vector in non-prime or natural basis, here it is E, but I can also write the same thing in non-prime basis also. In non-prime basis it will be, so let me write the total thing. So, x in say original natural basis is 2 E1 plus 5 E2, x in prime basis is this component that I figure out 7 by 2 E1 prime plus 3 to E2 prime. So, I can, if you think, I can write any vector in terms of whatever the basis I like. For example, this is the most natural way to write the entire vector, that is why the basis is natural, but the point is I can also write the same vector in another basis. Only thing is that the component is going to change, and if I want to find out the component, this is the rule. I need to use this rule to find the component, this component in any basis which is not natural. But one thing I need to know, that this T matrix, I need to know the T matrix which transform this component to the component which is in prime basis. Okay. So, one important thing we know here, that one vector can be transformed to any of the bases that we know, but most importantly how I can transform this to this is given by this rule. So, I just need to know how this these unit vectors or the bases are transformed to each other, that is why it is called the transformation of basis. Okay. I erase T matrix, but I may require this T matrix anyway, I can retrieve that. So, next thing, important thing is the condition of orthogonal transformation. Orthogonal transformation of basis. So, or rather orthonormal transformation of basis. So, make it more general. So, orthonormal transformation of basis. What is the meaning of that? What is the meaning of that? Say E1, E2, En are a set of vectors which are forming a basis where this condition is satisfied. This is the condition of orthonormality. I several times I mentioned. So, this is that. Now, I want to transform, I want to make a transformation, and I find another set of bases E1 prime, E2 prime, En prime. I can transform that through T matrix that I already shown. If I do that, then I demand that my new set of bases will also follow this formula. That means, my new set of bases will be also orthonormal. What is the condition for that? So, obviously, the transformation matrix T should be a special matrix that can transform this to this in such a way that the new basis will also be orthonormal. So, I know the problem, the definition of the problem is known. Now, let us try to find out the how this T matrix is play the important role. What will be the special condition? What will be the condition over T matrix? So, I should write EI like T I j E j prime, because this is the transformation rule that I am using. I am just writing in form of matrix component where j is running from 1 to n, suppose. I make a dual conjugate and I want to find out E k, which is T k L E L prime. Here L runs to 1 to n, where T k L is have to be star, because if you remember the dual conjugation thing, when I transform a kth vector to a bra vector, then which is multiplied with that, here it is a number, should be make in such a way that I can put a star here. So it is just changing the dimension from row to column. If you remember, this is changing. Also this has to be multiplied with this I need to put a complex conjugate of that. So that is why it is there. So now if I multiply this E k E I, in the right hand side I should write it as j 1 to n L 1 to n T I j T k L star E j prime E L prime, equation like this. Now the initial basis, the basis that I used or that is initially there is already orthonormal. So this condition was there. That is first. Second thing is that whatever the new basis I am getting should also follow that rule. That means I demand this has to be delta JL also. Now I put this both this condition here so that I can get a relationship here. So delta KL is equal to sum over J sum over L T I J T K L star, and this quantity I demand that this should be a delta function or delta JL kind of thing. This means whenever this is the dummy, both the J and L both are dummy indices. So if I run any one, so when L is equal to J, only this quantity will be 1, otherwise it will be 0. So I can remove my this integration and I can write something like T I J T K L is J, then only this term will survive. So I replace this L to J with a star. So I will have this. So let me write this equation here in the top. So finally I have J T I J T star K J is equal to delta of K J. This equation I got with putting all the condition. Now look carefully, what is the meaning of that? J is summed over here. So here is a J, here is a J. So few class back I already mentioned that when two matrices are multiplying, say A and B, if you remember, so let me remind once again. So A, B, two matrices are multiplied, then the component should be represented in. So, it is the AB multiplication IL component where J is this. So, the J should be put side by side, so that the valid matrix operation or matrix multiplication can be done. So, this is the rule, but here I find J and J sitting here and here, not here. So, I need to rotate these things, If I do that, then obviously I need to make a transformation, or I need to write the T matrix in a different way. So, if I do, then it will be Ij T j k dragger of that. What is the meaning of dragger? Dragger, let me explain quickly here. A, if a matrix A is A11, A12, A1n, A21, A2n, An1, Ann, this is the matrix A, where these are the matrix components. If I make a dragger of that, a dragger, that means first I need to make a transpose of this and then the complex conjugate. So, a dragger component will be something like A11 star, A12 star, A1n star. I make a transpose of this and then make a star of that. A21 star, A22 star, A2n star, An1 star to Ann star. So, transpose plus complex conjugate. So, one matrix is given, I make a transpose and then make a complex conjugate. Whatever the matrix I am getting, I can write as a dragger. So, here I am doing the same thing. When I rotate these things, eventually I am making the transpose of that, and then I remove this star. So, when I remove this star, I need to put a dragger. So, that means this operation is nothing but I am changing the matrix in such a way I can have my JJ here sitting. So, this is KJ. So, now this entire matrix having the form of matrix multiplication, T and T dagger is the two matrix which is multiplied. So, I can write this as T dagger of it is not Kj, it will Ki component. So, T dagger I j I k is delta Ki. So, that means T dagger component I generalize, I know now what is the components here. So, these components, if I look carefully, then I will find a beautiful thing which suggests that T dagger I k component which is equal to this quantity, that means when I and k are not equal, then this is 0, when I and k are equal, then this is 1. So, that means it is nothing but T dagger matrix is nothing but unity. A matrix multiplied by that dagger of that matrix gives you 1 is called unitary matrix. This is called unitary matrix, and this transformation has to be a unitary transformation. So, this transformation E to E prime, this transformation has to be unitary transformation, so that both the bases are forming a set of orthonormal bases. So, here E prime, E and prime, both the bases are forming orthonormal bases, under which condition they are transforming by a matrix T, but this T has to follow a rule, that is T dagger is equal to 1. This is called the unitary transformation. So, the take away lesson is, for unitary transformation when the matrix is T is related to this equation, which is a unitary matrix. Under that condition, if I transform one basis to another basis, if my first basis is a orthonormal basis, my final basis also be a orthonormal basis, only the condition is that my T matrix should be unitary in nature. So, with that today I will stop the class here. In the next class we again start with unitary matrix and show the example that I just showed today, that how the T matrix is forming a unitary matrix. So, with that let us conclude the class today. So, two very important concepts we learned here: what is the transformation of basis and the rule, how the vector components can be given, and another thing is that the unitary transformation, for which you can get a orthonormal set of basis from a orthonormal set of basis by using a suitable T matrix. With that, let us stop here. So, next class, see you in the next class where we deal with this unitary matrix in more detail. Thank you.